Alright, the next one we're going to do is, it's on the Calculus AB Section 2, and it's number 4. So it's number 4 total, basically. Okay, A says find the area of R. So the way you do this is you take the integral from, you see the value 9, 6 on your graph there. You can, oop, maybe. There, you can see it there. So 9, 6. So that means that you're going to go, you can either go from 0 to 6 or 0 to 9. It's easier to go from 0 to 9 based on the information, because you don't have to change the y equals 2 to the x or the y equals 6 values. You don't have to change those x values. So that's what we're going to do. We're going to go from 0 to 9, and you take the integral from 0 to 9, and then you take the value that's on top minus the value that's on bottom. So it's going to be the integral of 0 to 9, 6 minus 2 to the x, or 2 root x. So I'll try and get that close. There. In the A section. Right there at the bottom left hand of the screen. See it? And when you solve it all out, as you see here, it equals 18. Alright? Because once you find the integral, then you need to solve it in the range, or in the boundaries, 0 to 9. So, next part, B. We need to write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizon line y equals 7. So y equals 7 is going to be similar to y equals 6. It's greater than both y equals 6 and y equals 2 to the root x for the boundaries that we have. And so therefore what you're going to do is it's very similar. You're going to do the integral from 0 to 9 for 7 minus 2 root x, because 7 goes on top of, or 7 is above root x for the boundaries, minus 7 minus 6. Now the only thing that you add to it is you're rotating it about the horizon, so it's going about the horizon, or horizontal line. And so therefore it's cut up into like chunks, and these chunks are in squares. They're in squares, and so there's a square. And so what you have to do is you have to find, you're finding the volume. So the volume of a square is pi squared. So well, pi r squared, but r is your values on the inside. So what you have to do is you have to take those values that are on the inside, the 7 minus 2 to root x, and then the 7 minus 6, and you have to square them, both of them, and you also have to put a pi sign outside of the integral, so that you can properly do this. So here's what it looks like. So tricky. Let's see B right there. 0 to 9. So you see how we square the 7 minus 2 root x, and then you also square the 7 minus 6, and then don't forget your dx at the end. And that is the answer to that, because it says write it, do not solve it. C. Now, a little tricky. So it's talking about how region R is the base of the solid. Now it's 0 to 6. So it's not 0 to 9, it's just 0 to 6. So it's going the other way. We're using the x values. So it talks about how the height is 3 times the length of the base. So we need to, basically, first step is to change our y values, y equals whatever, to x values. So the one that we're going to be using is y equals 2 root x squared, because that has an x value in it. Y equals 6 doesn't. So you square both sides, and that comes out to y squared equals 4x, because 2 squared equals 4. Root x squared equals x. Then you divide by 4, and you come out with y squared over 4 equals x. Right there, where my finger's pointing. Boom. Okay. Now this is your value, and it says that the length of the base is the height is 3 times the length of the base. So height is going to be 3y squared over 4, and then you already know the base, which is y squared over 4, because the x value is y squared over 4, and then you don't need to figure out like what the height is, because you already have it. It's the same. It's just 3 times it, as you can see here. Boom. So then you multiply them together, as you see, and it becomes 3y4 over 16. So the actual answer is the integral of 0 to 6, 3y to the 4th power over 16 dy. Don't forget the dy. Alright. Alright. We're going to look at number 3. So to begin, just reading it, there are 700 people in line for a popular amusement park ride when the ride begins operation in the morning. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there's a line, people move onto the ride at a rate of 800 people per hour. The graph above shows the rate at which people arrive at the ride throughout the day. Time t is measured in hours from the time the ride begins operation. So it'll be a little tricky showing this to you guys, or teaching this, because I couldn't quite figure out the software to have it on facing my paper. So I'll just kind of do it on my paper, and then I'll show you, and I'll be explaining the whole time. So for part A, how many people arrive at the ride between t equals 0 and t equals 3? Show the computations. Okay, so what you're going to do is, when you look at the graph, you see that it's a trapezoid. So you got to use the trapezoidal sum theorem. And so what that looks like is, I'm going to tell you I'm going to lay out the answer, and then I'll explain it. So the answer is going to be 2 times 1,000 plus 1,200 over quantity over 2, plus 1,200 plus 800 quantity over 2. And where these values come from, the 1,000 comes from the t equals 0, and so that's 1,000 plus, and then the 1,200, 1,000 plus 1,200 is the t equals 2. Because from 0 to 2, the slope is the same, so you don't have to do 0, 1, 0, 2. You can just do 0, 2. And it's all over 2. Then you do, you have to do another one for 2 to 3, because the slope changes. So it's 1,200 plus 800 over 2, because it's value at 2, value at 3, all over 2. And so what this equals is 3,200 people, and as you can see here, one sec. A little tricky. You kind of see right here, but that's the answer. It's 3,200 people. Now B, is the number of people waiting in line to get on the ride increasing or decreasing between t equals 2 and t equals 3? Now this one, it's just pretty much I'm sure there's some mathematical equation you can figure out, but you can just do it by looking. At t equals 2, there's 1,200 people that are getting in line, and at t equals 3, there's 800 people getting in line. So in between those values, there's more than 800 people. Well, if you read the first part of 3, it says that only 800 people per ride are sent through the line, or move through the line. So therefore, if there's more than 800 people on or moving into the line, then the line is going to be increasing. Next, C. At what time t is the line for the ride the longest? How many people are in line at that time? Alright, so what you're going to do here is you can kind of, again, look at the graph to do it. What you're looking at is from 0 to 3, the graph is above 800 people for how many people are getting in the line per hour. So therefore, the line is going to be increasing until 3. Because after 3, from 3 to 8, when t equals 3 through t equals 8, the line, there's less than 800 people per hour that are getting into the line. So therefore, the line is getting smaller, because 800 people per hour can move through the line and onto the ride. So at t equals 3, there's the most amount of people waiting in line. because it's right before it drops off. People keep increasing in the line, and then at t equals 3, after t equals 3, it starts decreasing because there's less than 800 people per hour getting in line. Now, you need to figure out, the second part of this is you need to figure out how many people are in that line. So what you're going to do is you're going to kind of come up with an equation. Basically, what you're going to do is you're going to use the graph as well as the information given at the beginning. So to start off, there's 700 people in the line at the beginning, so you have 700 plus the 3200 from 0 to 3 that we found in A, because that's 0 to 3, that's how many people are in that line. Now you need to find, so that's all the addition that we will need. Now the other aspect that you have to think about is, and you have to factor in, is how many people are being moved through the line. So it's 800 people being moved through the line per hour, and that's over the course of 3 hours. So it's minus 800 times 3. I'll show you the equation. Hopefully you can see it. There. 700 plus 3200 minus 800 times 3. And what that equals is 1500 people. So at t equals 3, the time when there's the most amount of people in line, there's 1500 people in line. Last part of this question, write but do not solve an equation involving an integral expression of r whose solution gives the earliest time t at which there is no longer a line for the ride. This one's tricky. The biggest thing is when you have these problems, you're gonna, obviously the integral, it's tricky figuring out a couple things. One is finding what are the boundaries of the integral. And so the boundaries are from 0 to t, because it's stopping at t, the earliest time at t where there's no longer a line for the ride, and you don't know necessarily, like the beginning 0. So now what the integral is going to be is you have to factor in that there's 700 people to start. So, and that's not part of the integral because it's not like an equation that has to do with like a t value or something like that. So that goes on the outside of the integral. Now the next thing you do, here I'll show you that. Right there, 700 plus 0 to the t. And next we get into the next part. Now Rs is the rate at which people are moving through. And so you find the integral from 0 to t of the rate minus 800t, because that's how many people are being moved through the line each hour. So it's basically the rate that people are moving through into the line minus the rate of people being moved onto the ride and off and out of the line, basically. So it's just taking the integral of that. And the biggest thing is, can't forget the 700. So I'll show it one more time. It's right there. That's your equation. And that's it. All right. I guess I'm done.